In this video, I'm going to show you how you can build this Orderbook visualization here using Plotly Dash and Python. We don't need any JavaScript or fancy web development skills. We can do this right in Python using the magical powers of Plotly Dash. As you can see, we're streaming in live Orderbook data. In this particular case, we're streaming data from Binance, but the front-end dashboard that we've built here is compatible with a wide range of data sources. So with a bit of tinkering, you could easily get this working if, for example, you source Orderbook data from a different API or from your own local database. We've got a few different drop-downs here that we can use to control the output. We can set the aggregation level, so I've currently got it set to $1, and so we have $1 price increments here on the bid and the asks. But I could set that to $10 if I wanted to here for ETH USDT. I can also change the pair. You can add as many pairs as you like. Could change this to Sol USDT. Obviously, Solana is a lower priced asset right now, so we get fewer price levels. But we can just move down the aggregation level here down to 0.01 or 0.1, which can give us a clearer view on the market. We can also change the precision at which we're viewing things here. So I could change this to 3 decimal places or 4 decimal places. And if we have the precision given to us by our broker, that will show up right here. And we'll do a lot of work formatting all this stuff to make sure it's nice and clean. The text stays in the center. We don't have any problems with the columns shifting about. And overall, we're trying to emulate the look of the Binance Orderbook. But once you've built this project, you'll have the confidence to take on much more advanced projects in Plotly and be able to customize it for yourself and your own needs in your own trading dashboard. You can update the Orderbook much more frequently than we are here, but we're limited by the rate limit on the Binance API. So if you have a different data source, you can update this pretty much near real time, maybe every 300-400 milliseconds. You don't need a massive amount of experience with Plotly to get started here. And over the course of this project, you'll acquire a good amount of familiarity with the fundamental aspects of how Plotly works and how you can create more advanced dashboards like this one for yourself. So let's dig into Python here and we can start constructing this dashboard. So I'll first just exit out of the setup we have here. You can't run 2 Plotly Dash instances on the same port. So I'll just stop this one from running using Control-C, and then I'll exit the terminal. And I have a new file set up here. This is just some Plotly Dash boilerplate. So I've got dash bootstrap components, as well as pandas and requests installed. You'll want to go ahead and pip install all of those different modules if you don't already have them on your system. Here I'm creating our app with an external style sheet. So in this case, it's the Cyborg theme. There's lots of other themes you can choose from. If you go to bootswatch.com, they're all on there. I chose Cyborg just because it's a dark theme and it looks cool. We've got the app.layout here. This is where you input all of your different components. Here we've just got a simple div, so just an empty container. And then this bit of code here just tells Python if we're running this file directly. So we're not importing it as a module in a different file. If we're running this file directly, then start the server and debug equals true. So let's run that and it'll give you a link here. You can open this in a new tab and there's nothing going on here. We've just got a plain background, nothing interesting is happening. And that's because we just had an empty div. We don't actually have any content in here. I'd recommend if you're following along with this tutorial that you do everything in a regular Python file, so a regular .py file. I believe it is possible to get Plotly Dash working in a Jupyter Notebook environment, but you require a slightly different method of running the server than the way I'm using here. So if you want to follow along with exactly what I'm doing, I'd recommend sticking with a simple .py file. In the first part of this video, I'm going to focus as much as I can on just building the functionality that we need, and then we'll focus on styling and making everything look nice in the latter half of the video. And so what we need to do here is create a data table. So you can see I imported --table there, and inside this div, we can place a child element. So if I say children is equal to a regular old list, then inside that list, I can say I want a data table, which is just --table.data table. At this point, we'll just give it an ID here. So I'll set ID is equal to, let's say this is going to be the bid table. And for now, we can just leave it empty like that. We're going to be using a callback to insert the data into it. It doesn't need any default information, and we're not worried about styling at the minute. And so now we've got that data table, we need some information to put into it. And as I mentioned before, I'm going to use a callback here, so app.callback. And inside here, we can specify our inputs and our outputs to this function. And so the main output of this function, at least for now, is we're going to output into this bid table here. We're going to output into the data element of this table. So this table has a parameter called data, and we could set all of the values of the different columns and rows, but we don't want to do that manually and have it be fixed. We want to set that data attribute dynamically using this callback. And so that's what this output is doing here. And in order to activate this callback, I'm going to use an interval here. So that's going to be dcc.interval. Set an ID on it. I'm just going to call it timer. And then an interval in milliseconds. I'll set it to 3000 for now. So that's once every 3 seconds. And what that will let us do is it will let us run this callback on regular intervals. So we're regularly scraping the book data from our data source, as we need some method of activating this function. We could have it so that you press a button, and when you press the button, we fetch new data, but I think using a timer is more sensible here. And so we'll add an input, and whenever one of these inputs changes, Plotly Dash will automatically rerun this function for us, and therefore send the output data into this data table. So the input is going to be timer. This is the ID of the timer. And we can select a value that we want to insert into our function. I'm just going to use n intervals. I'm not actually going to use that in any meaningful way. It's just so I can have this timer as an input here. Then we can go ahead and define our function here. So I'll call it update Orderbook. Doesn't really matter what you call it. We only have one input to the function, that being the number of intervals. So I'll just call that n_intervals. We're not going to use it anyway, like I mentioned. And so this function is going to be doing most of the heavy lifting in our program. It's going to be responsible for grabbing the data, processing it, making sure it looks nice, aggregating all the price levels, and then finally exporting it to the bid table, and of course the ask table. We'll build that in later on. But for now, we need to start simple and just get the order book data in any format that we can get. So if we go to the Binance documentation here, this is the order book endpoint that we'll want to grab information from. You can see that's at /API/v3/neph. And then you need the base URL as well. You'll find that towards the top here. So I'll grab this link. And I'll set the URL like this. And then to grab the specific endpoint that we're after, just go down to wherever the order book is. So it's over here, /API/v3/depth. I'll paste that into our URL here. I'm using Binance here in order to grab the order book, but very little of this tutorial is specific to Binance. If you're using a different exchange or you've got your own setup for retrieving order book data in your own database, that's perfectly fine. You can just replace the 3 or 4 lines I'm using here to get the order book. For Binance here, we can see we have to provide 2 parameters. So the symbol as a string, so that's just going to be something like BTC USDT. And then we provide the limit, which is just the number of price levels above and below the mid price that you want. So if you ask for 100, you get 100 bids and 100 asks, if there are that many price levels on the book. So let's go ahead and add those in here. So I'll set my params is going to be equal to a dictionary. It's going to have the symbol. For now, I'll just hard code that. I'll set it to, let's say, ETH USDT. And we'll also want a limit in here. For now, I'll set that to be 100. It's not massively important either way at this stage. And then in order to get the order book, that's pretty easy. You just do data is equal to requests.get URL, set your params here, and then do .json. Again, if you want to use your own data source here, you pretty much only have to change these 3 lines in the whole program. Everything else will work exactly the same, provided that your order book data looks similar to the output that we're getting here, which it should do. So I'll print out the data here and we'll see what that looks like. Hopefully it should run. There you go. You can see we're getting a bunch of bid and ask data here. So this is the format it comes in from Binance. Any other exchange should have a similar format really. So you get the ID of the update. This is not really relevant to us, but it's important if you're replaying an order book. And then you've got the bids, which is a list of lists. And each list contains the price level and then the quantity available at that price level. And there's a very similar setup down here for the asks. Again, a list of lists. Thankfully, this is really easy to convert into a pandas data frame, which makes life simple for us doing data analysis. And so I'll create a data frame called bid.df here, so bid_df, and that's just going to be equal to pd.dataframe, and then I'll pass in data bids. So that will construct a data frame out of our bids here, and I can print that out to show you that it actually worked. Sometimes you have to go run the URL here to see what's happening. So it looks like there's an error here because I mistyped data frame. You actually need a capital F here. Let's run that again. There we go. You can see the bids coming in here with the price levels, followed by the quantity available. I'll change up the column names here just so that we can see what's happening. So just in here, we can set the columns, and I'll just set them equal to price and then quantity. What I'll also do at this stage is convert them to a float type. So at the minute, they're strings, which is great for precision. So if I just show you here, they're currently listed as strings, which is why you've got all these trailing zeros here. And that's great for precision. But if we want to do any kind of calculation from these values, they'll need to be converted to a numeric type. I'm going to use float here, and I haven't had any problems with it so far. Although if you wanted to be extra safe, you could convert this to an integer here. So you move the decimal point along a few and then store this whole thing as an integer. But I'll show you at the end that using floats just gives us the same answer. So we can just use floats for now. So let's go ahead and display that data that we've just gathered here from this data frame. And the way you do that is, well, we're outputting it here from our function, or at least we've told plotly dash that we're going to output it. So let's go ahead and actually do that. So we just need to do a regular return here. And then we'll pass in the bid df. But we need to convert that into a format that data tables understand. And you can do that with to_dict and records. I believe that converts it over to a list of dictionaries or something like that. I can just print it out here to see what's happening. Yeah, you can see it gets converted to a list of dictionaries, and each dictionary represents one row in the table. If we go to our display up here, you can see this is now working. So every 3 seconds, these are getting updated. Obviously, the styling is not exactly what we would like. This table is taking up the whole page, but we'll deal with that later on. It can often be a good idea to keep an eye on this callback graph down here. So we're going to be doing lots of relatively heavy and most certainly inefficient calculations today. And so we want to make sure that this calculation time here isn't getting too out of control, because otherwise we're not going to be able to update the display as regularly as we want. I think we'll be fine here with a 3-second update time. That should be good enough for most people anyway, and if not, you can work on optimizing this later on. So let's add just a little bit of styling to this, just to make sure it doesn't take up the whole page and we have room for other stuff. To accomplish that, we can just add some inline styling here into the layout. So if we go up here, what I'll do is I'll encase this data table inside a div. So html.div, I'll encase that inside a div, so another children object. Close that out there. And then I can style this div, so style is equal to, and at this point you can add regular old CSS in here. So I can say that I want the width of this div here to be 300 pixels. So I can do 300 pixels. And that's going to force the data table to fit within those boundaries. So we should be able to see that in action. You do need to make sure that you've got commas after all of these elements. So this is, after all, a regular list. So after you close out the div here, you need to make sure you keep those commas in there. Children is not defined because I didn't put an equals sign in here. Okay, so we've at least constrained the width of the thing. Now let's just make sure that we're not including every single one of the rows, because this is a bit much. In reality, when we're displaying the bids, we only really want to show the top few bids most of the time. Or we at least want it to be configurable how many of them we show. So I'll write that in here. We'll add a variable called levels to show here. And I'll set that to 10 for now. And then we can just trim down bid df here. So bid df is equal to bid df.eloc. And we'll just slice up to levels to show. If you saw in the data frame beforehand, you would have seen that the largest bids are at the top. So if we go out here, you can see that the largest bids are at the start of the data frame. So you just want the 10 largest bids. And that should be good to go here. We're just limiting it to 10. Let's run it and see what happens. You can just visit the same web page if you have it open. If not, you'll just open a new link there. So that's looking good. We've got our list of top bids here. It's not looking amazingly pretty, but we'll make it beautiful later on. For now, we'll focus on function. And I suppose naturally the next function we really want to think about here is aggregating this to different price levels. So right now we're just seeing the top 10 bids in the book, and they're a bit too granular to understand anything that's going on. It's very difficult to get any meaningful information from this if you were just keeping an eye on this, because each of these orders are being filled and removed from the book so quickly that by the time you see them, it's basically useless information. You know, if we set to the lowest granularity here on the ETH USDT pair, you can see that setting them at this level is not hugely useful because the price of ETH is moving by maybe 10 of these levels every second on a relatively regular basis. So how do we fix that? Short answer is we need to add a new function that'll do that for us, that'll take the full list of bids and condense it down to a given level of granularity that we give it. I have a full video on this if you really want to see all of the different intricacies of how we aggregate an order book, and I'll leave that in the description below. And so if I go a little bit too quick here when I'm writing this aggregation function, you can go and check out that video for a little bit more detail. I'm writing this as an extra function here because we're going to need to apply basically the same thing to the bid and the ask. So we might as well write one function that does everything for us, and then we can just call it twice, once for the bid, once for the ask. So we have two parameters that we're passing in here. I want to pass in the levels data frame, so either the bid or the ask levels. And I also want to pass in the side, whether that's a bid or an ask. We also need to add in the aggregation level here, so ag level. For now, I'll just set a default, but we'll make this customizable with the drop down like you saw earlier. For now, I'll just set it to, let's say, 0.1 here. So I'm providing this as a decimal value, which is quite important. It's important that this value be exact because we're going to use it to define the borders of which price levels belong in which price grouping. I'll also set this to bid for now, since we're just going to be using the bid book, but again, we'll make this dynamic in a second. And so essentially, what we need to aggregate this order book into different price levels is we need to figure out all of these different buckets here. So we've got the 1210 to the 1220 to the 1230. We need to figure out all of these different numbers here, all of these multiples of, in this case, 10, but it would be just whatever multiple of the interval that lies within the range of values that we get for the bits. We need to have all the multiples of interval that cover the lowest and the highest values in order to make sure that every value is aggregated. So to get the minimum value here, the minimum level, what we'll do is we'll get the minimum value of levels df.price. So we want the minimum value in the bid, so the smallest bid that's currently in the book. I'll convert it to a decimal here. You'll see why in a second. And then I'll divide it by the aggregation level. So what that's going to say is get the smallest bid value and divide it by this interval. Or in other words, how many intervals go into the smallest value? That's basically the question that we're asking here. So let's say the smallest value was $1,000.14. What we're trying to do ultimately is round that number down to the nearest multiple of this aggregation level. So round it down to the nearest 10 cents. So we divide it by 10 cents. That gives us $10,001.40. We round this number down to the nearest integer with math.floor, and then we multiply the whole thing again by our aggregation level. And if you do the math there, basically what this complicated formula does is rounds this minimal value down to the nearest multiple in here. So if I input $1,000.14, it'd be rounded down to $1,000.10. And this works for any aggregation level and any price here. The reason we converted this to decimal here is because we're dividing by a decimal number. So they need to be in the same numeric format. And as a bonus, we're multiplying a decimal by an integer. We get another decimal object, which means if we do any math with this, it's going to be precise. So that's how we get the minimum value here. What I'm going to do is I'm going to take -1 off here. That's just important to catch some edge cases. So if the minimal value of the price levels happen to be an exact multiple of this, our order book levels would be slightly off. We wouldn't have an interval for it to fit into. So we want to make this range a little bit wider just to make sure we catch everything. Now, you want to do much the same process here to get the maximal value, except instead of floor, it's going to be ceil to get the next integer upwards. And you'll want to use max instead of min, obviously. And then instead of minusing 1, we'll add 1. So these numbers just give us the bounds here for our aggregation levels. And we're now in a position where we can calculate all of the different bins. So level bounds is going to be equal to a list comprehension here, because we want to generate multiple bounds. We want to start at the lowest possible level. So we don't have any bids less than this number, so we can start there happily. And we want to add our aggregation level multiplied by some number. So 1, 2, 3. We want to keep counting up in intervals of our aggregation level. 4x in range here. I'll go into a new line. And what's the maximal value of x here? Well, it's the amount of intervals between these two numbers here. So if our interval is 10 cents and these are 50 cents apart, we want to have 5 intervals. The way I'm going to write that here is I want the max level minus the min level divided by the aggregation level here. I'll convert this to an integer to make sure that range can read it here. And I'll also add 1 for good measure, just to make sure that we're including the full range. It doesn't matter too much if we have extra price levels, because at the end of this function, I'll remove all the price levels with no volume in them. So that's good here. These level bounds represent these different numbers here. So if I put this on 10 cents, we've essentially generated this list here, this column on the left. Now what we need to do is we need to generate the column on the right. We need to figure out how much volume is in each of these buckets and aggregate it all up. So let's create a new column in this levels data frame here, and I'll call it bin. And that's going to be the bin which each level in the order book belongs to. So again, if we had $1,000 and 14 cents, and that was in the order book here at an aggregation level of 0.1, that would belong in the bin that goes from 1,010 cents to 1,020 cents. The way we implement that in Python is we use this fancy pd.cut function here. We put in our prices here, so levels df.price. We set our different bins here equal to the level bounds. We set a precision, so that's how precise you want to keep the bins. By default, it's 3, which should be enough, but I'm going to set it to 10 to make sure things are done properly. And then finally, we have this variable called right in here. And what this does is it decides whether a value on the right edge of the bin should be included. So if this bin goes from $1,000.10 to $1,000.20, should a value of 1,020 cents go into the bin or not? Or should it be included in the next bin? This actually differs for bid and ask sides of the order book, if you think about it. For the ask side of the order book here, we're including everything up until this number, so right is equal to true in this case. Whereas for the bid side of the order book here, we don't want to include the right edge here. So if I just move this up to a bigger aggregation, this bucket here from 1180 to 1190, we wouldn't want to include a value of 1190 in there. If a price level existed at that point, that would go into the next bucket up. If you sit and look at the order book for a while, you'll see why that's the case. So in our case, we've got side equal to bid, and therefore right is equal to false. Now you can just set it here like this, but in the interest of making this function reusable for the bids and the asks, we can check to see the value of side here. So if side is equal to bid, then right is going to be equal to false. And if side is equal to ask, then we want right is equal to true. And that way we can do this programmatically and reuse our function. I've also noticed up here that I didn't convert this value here. So currently this is going to be a decimal. So min level is a decimal because we multiplied by a decimal. Ag level is a decimal, and this is an int. So this is also going to be a decimal. 2 decimals added together is another decimal. And pd.cut does not understand decimals. At least I couldn't get it to work with decimals. So after we've done this calculation, we'll then convert it to a float, which is safe because we're not doing any further calculations to it. The dangerous part is this bit here, where you're multiplying this number by an integer repeatedly. If this value was a float, we could end up in some serious trouble, but thankfully it's a decimal, so things are going to be accurate. Okay, so this might all seem a bit abstract at this point, which is why I'm going to print out this levels df. And what that's going to let us do is visualize our progress so far, and you can see what this bin function is doing and how we're going to proceed. So I believe this function is called aggregate levels, and I just need to pass in the levels df. So let's do that down here in our update orderbook function. So aggregate levels. I'll pass in the bid df here. Let's not print out these ones because they'll clog up my screen. And let's see what that looks like. I may have to open the window here for it to display. Okay, it looks like we're getting an error here. That is lovely. Aggregate level is not defined. I believe it's aggregate levels. Let's try that again. Okay, so you can see how this is working here and how the different values are being bucketed. You might want to do a quick check here. So we can see that this price level here, 1192.77, is being bucketed into 1192.7 to 1192.8, which is accurate. And you can check here that these values are also being binned accurately. All that remains here is to do an aggregation based on the bin. So all values which share a bin, their quantities should be summed together. That's all we really need to do here. So in this bucket, there'll be 8.3965 ETH. In this bucket, you add all these numbers together, etc., etc. Let's quickly do that. So down here in our aggregate levels function, we can do that with a quick group by here. So levels df, we'll just replace this whole value of data frame. And we'll set that equal to levels df.group by. We'll group that by bin dot ag. And then we only really need one column in here, and that's going to be the quantity. We don't actually need to include the price because this bin contains the price level. You just take one end of the bucket. Quantity is equal to quantity and sum. And then I'll do a dot reset index here. So what this function does by default is whatever you group by becomes the index. I can just show you here actually. I'll comment this out and I'll show you what that looks like. So we're grouping by the bin here. So the bin becomes the index here on the left hand side. I want to promote this to a column just so it's easier to handle. Can be a bit of a nightmare dealing with indexes. But we can see it's basically functioned here. It's added all the quantities together for each of these price levels. And later on, we'll compare that to the live order book so that we can check everything's actually working. So I'll promote this bin to a full column. You'll see what happens here. So you can see this bin is now a column and we've got regular integers on the index here. I just noticed the bins here are closed on the right hand side. Yes, I forgot to set right equal to our value there. So I gave that whole speech about setting this variable and then forgot to change it here. If I run this again, that should have fixed things. There we go. So you can see they're now closed on the left-hand side, which is what we want for the bids here. Now what we want to do is we want to create a new column here with the price label. So because this is the bids here, the buckets from 1190.8 to 1190.9, we would label that as the 1190.8 price level. Again, if you stare at an order book for a while, you'll see why that is. So let's go ahead and do that. The way I'm going to do it is I'm going to implement a lambda function. So I'm going to call it label func. And that's going to be lambda x.left. So this function is going to take the left boundary, and this function is going to take the right boundary. I'm just doing it this way because I can very easily reuse this function now for both bids and asks. So we'll take this lambda function and we'll apply that to the column here. So levels df. I'll create a new column. I'll call it price. And levels df price is going to be equal to levels df.bin .apply label func. So I'm just applying this function to all elements of this series, so every value of bin. Because this is a bid, it's going to grab the left-hand values, which is what we want. Again, just print it out, see what's happening. And we can see these bin labels are being set appropriately here. And we can now go ahead and get rid of this bin column. We don't really need it for anything. And we can also get rid of all rows where the quantity is 0. We don't want to display those in our order book, although that's personal preference. I guess you could if you wanted to. So let's remove all of the ones with 0 volume. So levels df is equal to levels df. Levels df dot quantity is greater than 0. So remove all the ones with quantity equal to 0. And then we can also do something like this. Levels df is equal to levels, I think I've typed this word out enough to last me a lifetime. Levels df, double brackets, and then the names. So price and quantity. And that should be good here. If I run that, we can now aggregate this to essentially arbitrary values here. I could go ahead and aggregate this to whole numbers. I could aggregate this to every dollar here. Now, we only requested 100 price levels, so that's why we've only got 2 columns here. But if I ask for more price data here, let's ask for 5,000 price levels. This should properly aggregate all of them. So you can see we've got 100 different price levels here, which is lovely. I'll turn this down to 1,000 for now, just to save on processing. And so at this point, we're basically done with this function. We can go ahead and implement it properly inside our update order book here. So we'll make it return the levels df here. So down at the bottom, we're printing it out, but we're not returning it. So let's return it here and return levels df. And so we can come back down here and we can set our bid df equal to the results of this ag levels here. So I can set the ag level equal to some other value, so decimal, let's say 0.1, and I'll set the side as well. So side is equal to bid. And there we go. That should work in our display now. So our values in our data table here are nicely aggregated to the 10 cents level, and it would just do the same if I aggregated it to the $1 level or the $10 level. It's the very same principle. At this point, we've got all of our basic functionality in place to visualize an order book. What I can do now is I can add in that drop down that we had before that will let us change the aggregation level here automatically without having to dive back into the code and change it manually here. So the way I'm going to implement that here is I'm going to create a function, and what the function is going to do is it's going to return a drop down element. So I'm going to define a function, regular old Python function here, no callback or anything required. and it's going to be called drop down option. So it's going to have a title, the option values that we want to be able to select, the default value here, so the default value, and also an ID here. I'm using the underscore here because if you use ID like that, it's a reserved keyword. And although dash does use it, I prefer not to mess with any of that, so I just use the dash there to signify that it's one of my local variables and not a reserved keyword. So inside this function, essentially what I want to return is a div here, so a container. And inside that div, if I set the children here, inside the div, I want to have a title, so h2, and that's going to contain the title here. So the aggregation level is going to be labeled aggregation level. And then I also want a drop down to go along with that. So dcc.dropdown. This is a regular dash core components module. It's just a drop down. And in order to get it to work, you need to provide the options. So I'm going to set that equal to my options. The value is going to be equal to default value. And the ID is going to be equal to my underscore ID here. And then I can close on out this div. And there we go. We've got this reusable component here. The reason I made this into a function is because we're going to be creating multiple of these drop downs. You can just take this code and insert it directly into the layout over here. But in my experience, it tends to get really, really messy. So instead of repeating all this code again and again, we can just call this function with the parameters that we want to set. So let's do that down here. I'll put them in a separate div because we're going to style them differently. Eventually, we're going to have them in that 2-column layout like I showed you earlier. We'll have a column with the bid and ask order book, and then we'll have a column with all the options and the dropdowns. That's what these two divs represent here, and it's why I'm putting the different objects in the different divs. So we can add an option here inside this div. So children is equal to an open square bracket. The first option that I want to add here, drop down option, is just going to be the aggregation level. So aggregate level. And if you remember the order of the different parameters that we provide, we first want to give it the options. Option is going to be equal to, I'm just going to hard code these in here, but you could come up with some fancy logic for automatically creating them. So we'll have 1 penny, 10 cents, $1, $10, and $100 in here. That's enough for what I need here. If you're trading some weird pairs and you need much more granularity, then you can obviously feel free to add more to that options list. We'll set a default value here, so default value. I'm going to set that to be 0.01. Make sure this value is included in this list. If it's not, I've had some strange stuff happen to me before. And then finally here, we just need to add in an ID. So ID is going to be equal to aggregation level. Seems like we're running off the screen here, so I'll fix that formatting. We'll bring the options up here. Okay, so we've got our aggregation level drop down here. Make sure to close out this div. Let's see what that looks like. So right now it has absolutely no functionality. It literally just has a drop down that doesn't do anything. Okay, so we can select different values and absolutely nothing happens to our table up here, but that's completely fine. Let's go ahead and add in that functionality. All we really have to do is add another input to this callback here. So we've got the timer input here, and that's going to trigger this callback. But we also want to trigger the callback whenever we change the aggregation level. We want it to immediately update and aggregate to whatever level we set it to. So the ID of that component, if you remember, was aggregation-level. And then the value that we want to pass in is just the value that's selected, so that's called value. And then inside our function here, I've got to remember to include that. So I'll call it ag level, and that will get passed into our function. Remember that ag level is a string here. So when we pass it in here with the ag level equals, we need to make sure to change that into a decimal because that is what this function expects. We can just replace that 0.1 there with ag underscore level. And now that should be functional. The dropdown should be working. Apparently not. Let's see what this error means. Yeah, so it looks like I messed up typing the ID in here. So this is aggregation dash level. This input here is aggregation dash level. Let's see. Yes, I use an underscore down here. That's always a danger, mixing underscores and dashes. But that should work now. Okay. So it's currently at 1 penny. Looks fine. Let's set it to 10 cents. Okay, also looks fine. $1, looks fine. $10. Okay, we're running out of data. We don't have enough price levels, but in theory at least, it's still working. And the levels look reasonable here. So I'm pretty happy with that. We can check the time it's taking here. It's not taking very long at all to compute that, so I'm very, very happy overall. While we're at it, we can add another one of these drop downs here to account for the symbol. So right now we're just grabbing ETH and that's hard coded in, but we can of course change that. So if I go back and add another drop down, all I have to do is copy and paste these two lines essentially. Instead of the aggregation here, it's going to be the pair. And then let's just set some common pairs in here. So we'll do BTC USDT. ETH USDT, I'll set Sol USDT, and then I'll also do B dot dot. Now that's quite an exotic pair there, but the reason why I'm using that is because it's not traded very often. The order book's very still, and therefore it's easy to compare what our order book looks like to what the Binance order book looks like, to check our work and make sure our order book is actually aggregating properly. Okay, so the default value I'll just set to ETH, that's fine. And this ID here, I'll just set as symbol select. Or maybe pair select here. Alright, so very simple again to add that down here. So aggregate value, this is going to be pair select. Again, we want to extract the value. And we can just add this in as a symbol. And then all we have to do to get this drop down to work is plug it in here. So symbol. I'll do symbol.upper just to make sure it's in uppercase. Binance does, I believe, demand that the symbol be in uppercase. So when we pass that through to the request there, we should be able to get whatever symbol we want. This is unhappy. Let's see what's gone wrong. I suspect it's the curse of the comma here. Yes, we need to make sure that we're adding commas to the end of these lines because they are ultimately objects in a list and we need to separate those with commas. So let's have a look. Yes, we can switch the pair here. Looks right to me, and those look like Bitcoin prices. Those, on the other hand, do not look like accurate Sol prices. So something's gone wrong here, but we can debug in a minute. So we can see here that the prices seem to be going in increasing order here when we go down. So it looks like something is sorted in the wrong way. In order to mitigate that, let's do a sort descending here at some point. So we'll get the aggregate levels here. And then we'll do bid df is equal to bid underscore df dot sort values. We'll sort by price and we'll sort in descending order. So ascending equals false here. It's why it's a good idea to print stuff out so you can see when things go wrong like that. And so now if we pull up Sol data, okay, this is now looking reasonable. And we can aggregate that to whatever level we want, as I did before. Let's add a little bit of styling in here. So I'll separate these out into their two columns and I'll make sure these are on the right hand side and that it's at least a little bit prettier than where it is right now. So I'll go back into here. And the way I'm going to fix that is all going to be inside layout up here. So these two divs, I'm going to put them inside a master div here. So html.div. Children is equal to list. These are just now items in my new div. And then I can create a inline styling parameter here. So style is equal to, and I'm going to use flexbox here, which you may have come across before, to magically make sure everything's all aligned properly here. So I'll set display equal to flex. So this will make the columns appear at the side of each other rather than being underneath. I can also apply a few settings here. So I can say justify content, and I'll set that to center. And then there's another one here which does align items, center. And basically what these do is make sure that the items are centered in the middle. So I think this one centers everything left to right horizontally, and this item will center everything vertically. In order to do that, I'll have to set the view height here. So height is going to be equal to 100 times the view height. So basically the entire screen. And what that will do is allow align items here to do its job. If you don't set this, then things won't be centered vertically. So I think that should work now if we give it a run. It's complaining that my syntax is off. Yes, I need to close that on out and add another one of the dreaded commas there. So let's have a look at that. Okay, so this is now pretty much working. We need to add a little bit of padding on this side here. It doesn't look too great at the minute. So on this option here, with all of the different drop downs, we can just add another bit of styling here. So style is equal to, and then just set some padding left. Let's set maybe 100 pixels of padding. That should be enough, hopefully. Have a look at that. There we go. That's good enough. For now, we don't need it to be absolutely perfect here. And so at this stage, I might as well go ahead and add the asks in here as well. So these are the bids. Let's go ahead and add the asks in. And that's going to be really, really simple now that we've got all this infrastructure in place here. So I can just pretty much copy and paste this data table here, and we'll have an ask table. Although we really want asks to be above the bids, so I'll put them in that order. And then over here, we can create a asks data frame. So we created the bid data frame here. Let's create the ask data frame. Everything else is pretty much the same, price and quantity. Copy these two here, paste them in, and we'll just change them to say ask instead of bid, essentially. Ask df. And then it just needs to say ask as the side here. Make sure it's grouped properly, since the ask needs to have right equal to true, whereas the bid has the opposite. When we're sorting the values here, we're going to sort in descending order, which is fine. But instead of the bid df here, where we want the largest of the bids, we actually want the smallest of the asks. So ask df when we're displaying this. So instead of doing it like this, we'll do the slice this way. So in minus levels to show until the end. And then we need to add a new output in here. So we're not only outputting to the bid table, we're also outputting to the ask table here. Pretty simple to add that on. You just do ask df.to_dict and then records. Let's run that, see what happens. Okay, we've got some sort of error here. Yes, it's asks, not ask. That's got me quite a few times today. There we go. Okay, so those are joined together, which is not massively helpful, but we can at least see that they look correct. I'm basically just checking that this value is always larger than this value, and that they all go in descending order, which is what we want. I'm going to trust that our aggregation here did the correct thing, but we'll verify that by checking against a different pair later on. Aggregation seems to work fine. Obviously, there are a few styling things here we need to improve on, but overall looks pretty good. Let's add the mid price in here in the center so we can see what's happening. Again, that'll be pretty simple to add. We just need to go up into the layout here. We'll add an h2 in here, so html.h2. We'll give it an ID, so that's just going to be price, let's say. Or we could call it mid price, I guess, to be accurate, mid price. We'll add that as an output of our callback here. So output mid price. And we'll output to the children attribute. Then all I have to do is go over here, and the mid price, well, that's just going to be equal to the largest bid plus the smallest ask divided by 2. So it's going to be bid df.eloc0, or I guess more accurately, bid df.price.eloc0 plus ask df.price.eloc-1, all divided by 2 here. And then I can print that one out, so mid price, return that as part of our function here. And then hopefully it should show up. A non-existent object was used as an output, yes. Underscores versus dash again. So it's mid dash price. I should really standardize this. But there we go. That seems to be working. Again, it's going crazy here with all the zeros because it's a floating point value. But we'll worry about that in a second here. For now, I'm just happy it's actually displaying. So let's add those 2 other drop downs that I had on the side here that affect the amount of decimal places shown for the quantity and for the price. Again, I'm sure you could have some fancy algorithm that works it all out for you, but for now the manual option works just fine. The reason why we want to have a consistent amount of decimal points between them is it's way easier to read the book if they're all perfectly aligned. So if you look at the Binance order book here, you can see that because they all have the same amount of decimal points and they're all centered at this point, it's very easy to see what's going on. Whereas if the numbers are shifting about from left to right, very difficult to read. So let's go fix those. It should be fairly simple. So we just go back to our layout up here and we add in a few new drop downs. So this one is going to be called quantity precision. I'll put the options on a new line here since we seem to be running out of space. And then we just want to provide the levels of precision. So it's going to be 0, 1, 2, and 3. I guess we'll add a 4 in here as well. So this is the amount of decimal places, so 0, 1, 2, 3, 4. And then I'll do the exact same thing down here, but I'll do it for the prices instead. So price precision. And we'll have 0 to 4 decimal places, that's fine. The default value, I guess, I'll just leave as 2 here. And then the ID can be quantity precision, and the same thing down here for the price. So price precision and a 2 here for the default value. So that should be good unless I've messed anything up, but the interpreter will tell me about that in a second. All we need to do for now is add a few more inputs in here. So after the aggregation level, let's add in quantity precision. And we'll also add in the price precision here. So price precision. And we have to add those to our inputs on the function here. So the actual function itself, quantity precision, and the price precision. Okay, so we've added them to the function. Now we need to make them actually do something. We essentially just need to format the columns in the different data frames here. I'm going to do that using a lambda function to convert them to strings with a specific level of precision. Not the most precise thing in the world, but it gets the job done. So after we've got our bid and ask data frames defined, down here, let's start setting the values. So we'll start with, let's say, the quantities, because they're most likely to have these floating point errors. So bid underscore df dot quantity. So this is the amount of volume in a given price level, is going to be equal to the quantity column, but we're going to apply a function to it. So this is going to be lambda x. And we're going to pass that into a formatting string here. So percentage dot, then quantity, precision, f, percentage, x should do the job here. Let's give it a test in a second and we'll see how it works. We'll do the same thing for ask here. So ask df.quantity is equal to this. If you're wondering how this string works here, you may have seen it before if you've messed about with tick formatting in matplotlib. There's this string formatting language you can use, but essentially all we need to know is that whatever number you put in here before the f, that's how many decimal places it will cut the string to. So let's see if that works. All right, it looks like I've got a double equals sign somewhere. A good start. Yeah, over here. Error updating. Okay, it's saying there's an error here, but I don't really believe it because it seems to be working, so we'll see if that error persists. Go to 3 decimal places here, that's no problem. 4 decimal places, again, no problem. So let's go ahead and add that in for the prices as well. Now, it's not as important as with the quantities, but you can see when the price is ending with a 0, so if it's 0.4 flat here, you can see that it doesn't print out the number formatted properly here. So I'll do the exact same thing, but just for the prices here to make sure they're printed out to the right level of precision. Should be fairly easy to do down here. So instead of the quantity here, we just do the price, so dot quantity, or rather dot price, and price precision. And copy and paste that down here, and ask instead of bid. I'll also do the same thing for the mid price while I'm here, because why not? So I'll copy that lambda function, and I'll just do something like this instead. So I'll do mid price is equal to all of this, and then mid price here. Now you might want to add more precision to the mid price than you add to the regular price labels. But for now, I'll just leave it like this. That should be fine here. Have an unmatched, yeah, it's over there, delete that. Okay, let's see what that looks like now. So much easier to read. Everything's nicely organized here. We can aggregate that to the $1 level. Much, much easier to read. So that's pretty much all of the functionality of this dashboard. What we're going to be doing in this part of the video is we're going to be adding all of the styling here. So we're going to add that fancy coloring, the fancy gradient here that shows you how much volume there is visually. We're going to change the text colors here. And we're also going to get rid of these headers because they just get in the way. So let's go ahead and do all of that. There is a cool example in the documentation that does pretty much what we're trying to do. So the code I use in this video is adapted from here. So you'll see it looks very much the same, but simplified a little bit. But you can check that out on the plotly dash documentation if you want to dive further into how this function works. Let's dig into Python though. So we'll create a new function here called table styling. That's how this is going to work. So up here near the aggregate levels, we'll create a new function and we'll call it table styling. And basically what this is going to do is it's going to take in our data frame here, as well as the side, so whether that's bid or ask. And what it's going to return to us is a list of dictionaries. And those dictionaries are essentially going to contain styling components that will be applied to the table. So there might be one to change the color to red or green, and there'll be many, many of them in order to get that gradient effect that we saw earlier. So I suppose we can start off here just by changing some basic coloring to get the idea of how this works. So if side is equal to ask, well, the ask we're going to display in red. We're going to follow Binance's theme here. And so the bar color is going to be equal to RGBA. So RGBA 230, 31, 7, and 0.2. You can find a color picker online that will help you find different colors if you want to pick a different one. The important part about this is we've got an alpha channel in here, and that lets us choose a level of transparency. So this has a 20% opacity here, which means that you can see through it. So if we go back to here on Binance, you can see these red bars. They're not fully opaque. You can see through them. They've got some transparency on them. That's what this is emulating here. And then we've got the font color here. So I've got a bar color. That's going to be the background. And then the font color, it's going to be just the same thing, except I don't want the alpha channel there, so I'll get rid of that. Copy and paste this, and just do the same sort of thing for the bid side. The bid side is green, and the color there is 13, 230, and 49. So 13, 230, and 49. And then we need the background color of this theme here, so what color this is in the background. The way I got that is if you go to Bootswatch here, so if you go to Bootswatch and then whatever theme you've decided to use, so I used Cyborg here, but there's loads of different ones. What I did to get that hex value is I downloaded variables.scss here. So I downloaded that file that's on my desktop. And then if I go open it, you can look in the text editor and you can find the variable that you're after. So for me, it was the body background here. And this is the hex value that we'll want to add. So I'll copy that and we'll paste that into our program here. Obviously, if you've got your own theme, your own background color, use that one. But that's how you can find the background colors for the Bootswatch themes. So cell BG color is going to be equal to that hex value that we just got. That's going to be a bit important later on. For now though, let's just create a list here. So styles is equal to this, and we'll append a dictionary containing styling instructions to that style list. So styles.append, open up a dictionary here, and this is a conditional styling. So if the column ID is equal to price, then what I want you to do is set color equal to font color. So obviously, depending on whether it's a bid or an ask, that will be slightly different. And then we'll just return styles here. So all this is attempting to do is change the coloring of the price column here. So this should be the red or green, depending. In order to actually get this to work here, we're going to have to add some more outputs here to our callback. So this is our master function. It gets called every 3 seconds. Let's add some new outputs to it. So I'll just copy and paste this one. And we're going to inject some conditional styling data into this table. So it's style data conditional. And this data here is just going to be that dictionary that I showed you, that style dictionary. So let's copy that, and we'll also do it for the ask table here, ask table. And so all we need to do is we need to add that in our output down here. So we're outputting the data. Then we want to output table styling. We'll include our bid data frame as well as the side here, so that's bid. And then we'll want to do the exact same thing for asks here. What I'm going to do is I'm going to wrap the whole thing in brackets here, and that way I can break off a new line and Python won't complain at me. And then after the ask here, you want to put table styling, ask df, and ask. So we're just calling that function as normal. Do remember that the order here is important. So the order from left to right here should be the same as the order from top to bottom. So this is your first output, this is the second output, third, fourth, etc., etc. So you get to the last one. So we'll see if that does anything. I think we may have to make a few more modifications before it will actually work with the styles here. But let's see what happens. If I go over here, open dash, nope, that seems to have worked fine. The reason why I thought it might not work is it might not have set the column ID here. That's what we use to say if the column ID is equal to price, then set the color. But that seems to have worked here, so I'm pretty happy with that. So that's the font here. We can also add the background color in. So we'll do the same sort of thing here, but if the column is equal to price, we want to set the color to font color and the background color here, background color. We want to set that to this cell background color over here, cell BG color, and we'll see if that works. There we go, that looks fine to me here. We're not going to worry about this column for now, that will get dealt with when we do the fancy gradient bar. For now, we can get rid of these headers though, they're not particularly nice looking. So we can go back up to our display here. We've got our two different data tables, and all you have to do to change the header or anything else is you can just add a styling dictionary in here. So we can set style header specifically is equal to display none, which if you know anything about CSS, that's going to get rid of it. Do the exact same thing for both tables here. So ID is equal to bid table. Same sort of thing, style header is equal to display none. You could set that to a variable and then avoid repeating the code here, but it should be fine for us. There we go, that looks a little bit neater. You can see what happens here is it actually leaves a gap where the header is supposed to be. I'm not sure if that's the intended behavior or not, but we'll want to mimic that on the other side to make this not look lopsided here. We can fix that by adding some padding to here. So style is equal to padding top, and then just set a number of pixels, so like 30 pixels or something. Seemed to be a number that worked well for me. Now these look a bit more symmetrical, which is nice. You may have noticed what just happened there, which is that this table just shoved itself inwards a little bit. You can see as the number of digits varies, this dividing line moves either side, which is really not nice to look at for long periods of time. And even more distressingly, what can happen is that the columns can be different widths on the different tables. So this column could be much larger in this table than it is in this table, which we really want to avoid. We can fix that by, yet again, providing another bit of styling here. What we essentially need to do is tell the cells that they can only be a certain size. So the min width, I can set that to be a certain number of pixels. So I'll set that to 140 in this case. And the way you force it to stay the same size is you can also set the maximum width. So the max width, I'm also going to set to 140 pixels. And then the actual width, I'm going to set to 140. All three of these are required as far as I'm aware. You have to include all of them, otherwise it won't work properly. Let's see what that looks like. So I'll copy this down into our other data table here. So copy that in. Let's see what that looks like. I'm just complaining about invalid syntax. The dreaded comma again. Cell, cell. Yes. This should be called style cell, not cell, cell. Style, cell. Let's see what that looks like here. So there we go. These are now the same width. It doesn't do that annoying thing where they change size. So that's ideal. Next quick fix I'll do here is center all the text. So it looks a bit better if all of these are in the middle rather than on the right hand side. That's a super easy fix. You just add an extra style tag in here. So you can do text, align, center. Pretty simple. And I can apply the same thing down here. And then I'll also apply that to my H2 here. So text, align, center. Give this a run. There we go, looking a lot nicer here. So finally, the thing you've been waiting for here, we're going to move on to creating this gradient here in this bar to make it look a lot more like this one here. It's going to take a reasonable amount of code, as I showed you before in this example from the docs, but stay with me here and we'll get through it. It involves changing our table styling function here. So we can leave all this stuff. It's this table styling function that we need to adapt here. And essentially how this is going to work conceptually is we create a bunch of buckets. So the quantities in our bid and ask are going to range from a certain value. So they might range from 0 to 100 Bitcoin, let's say. What we're going to do is we're going to create a number of bins here. So n bins. I'll set this equal to, let's say 25 for now. What our program's going to do is it's going to create 25 equally sized bins. The maths is very easy to do in our case because it's 0 to 100 Bitcoin. So the first bin is going to go from 0 to 4 Bitcoin. The second bin is going to go from 4 to 8, then 8 to 12, so on and so forth. And so what's going to happen is any value in the first bin is going to have a gradient that goes 1/25th along the bar. Anything that falls in the second bin is going to go 2/25ths along, which is 8%. That's basically how this is going to work. It gets a bit messy when we get into it, but just keep that conceptual framework in mind here. So we've got two variables that we want to create here. We've got bounds, and that is equal to I multiplied by 1.0 divide by n bins for I in range n bins plus 1. So all this is doing here is it's creating our buckets in percentage terms, basically. So the first element here is just going to be 0, and then the first one is going to be 4%. The second one's going to be 8%, so on and so forth. That's all this is doing here. Then we need another variable here called ranges. And what this is going to do is it's going to tell us what values of our quantity correspond to these different percentiles. So how far along is 4% through our data? So if our scale was 0 to 200, let's say that was the maximum and minimum in our quantities, 4% along would be 8 Bitcoin in. That's basically how this range works here. So to get the range here, we'll need the price. So the price is equal to df.price.asType float here. We'll just make sure it's converted to a float because we're doing some numerical calculations here. And what we want to do is we want to take the maximum, so the price.max, take away the minimum, so price.min. So this gets you the range of values. Multiply that by I here, and then add the minimum value here for I in bounds. So that's a lot to take in this list comprehension, but all it's doing is splitting up our range of data into different percentiles. If you don't want to think about it too much, you can just take it as a magical function. It's in the documentation here. You can just pretty much copy and paste what's been done up here if you don't want to dig into the details too much. So we've got all of our different ranges here. We've got all the different percentiles. And what we're going to do here is we're going to add a conditional styling dictionary here for every single percentile. So in our case, we're going to add 25 different conditional styling dictionaries to check how high the quantity is relative to the maximum and minimal values, and therefore assign how wide this bar should be. It's not the most performant technique in the world because we are adding 25 different possible conditional styling options here, so it does slow things down quite a lot. If your Plotly Dash is struggling, you can reduce the amount of bins here or just get rid of this function entirely. But let's go ahead and get started here. So for I in range, we'll start with 1 and we'll end at len bounds here. We're starting at 1 here because anything in the first bucket, we don't want to add a gradient at all to it. So in our example before, from 0 to 100, if it's 0 to 4, don't paint any gradient on it at all. And then if it's in 4 to 8, add a little bit, and then 8 to 12, add a bit more, etc., etc. But for I in this range, let's add an entry to styles here. So styles.append. We're going to append a dictionary, and it's going to have an if conditional associated with it, because this is, after all, being added to that conditional styles entry, if you remember the output from our callback. So the condition is going to be if. Then we're going to add a query here, so filter query. This allows us to access the value in the column. So if filter query, if the price here, so we can do price. If you enclose it in these double brackets here, that will grab the column value. If the price is greater than or equal to some minimum bound here, and it's less than some maximum bound, so, and the value of price here is less than some maximum bound, which I'll define in a second, then we want to apply our gradient here. So we'll need to do a couple of other things here. So I'll close out that string, and we can replace those values of min and max bound here by using dot format. So if I do dot format, min bound is equal to min bound, which we haven't yet defined, but I will in a second. And max bound is equal to max bound. We want to leave price as it is here, since that's just referring to a column. Now the max and the min bound here, so the max bound is just going to be ranges. So if you remember, this is just the different quantiles in our data. So it gives us the borders for the different percentiles. That's how we're establishing our max and min bounds here. So ranges I minus 1. So again, in our example, if you're in the first 4%, then you're in the first band. If you're in the next 4%, then you're in the next band, so on and so forth. We also want to check the column ID here. So column ID. Make sure to add a comma here. We want to check the column ID and make sure that's equal to quantity. So it shouldn't be price here, it should be quantity, because we only want to apply this data to the quantity section here. We've already set our styling for the price. We're pretty happy with what that looks like. The main thing we want to change here is the styling associated with the quantity. We'll also add a quick if statement here. So if I is less than the length of bounds, else nothing. Basically what this does is if I is the maximal value here, so if I is equal to the value of the length of bounds -1. So basically, if it's the largest possible value that it can be, we don't want to impose a maximum bound on it because it's in the largest category. So that's the end of the filtering here. We've got our if conditional. So if this is true, then apply the formatting that we want. Almost there now, just stick with it. So what do we want to apply if this filter is true? What we want to do is we want to change the background here, and we're going to apply a linear gradient on that background. So this is a regular thing in CSS. I hadn't come across it before, but it just allows you to paint gradients basically. So you select an angle that you want. This affects which way the gradient goes. So do you want the gradient to go top to bottom, bottom to down, left to right, right to left? For what we want to replicate what Binance has, 270 degrees is what you're after. Then what you do is you specify a color, a percentage on which that color should be. So how far across the page do you want that color to be? And then you do the same for the next color and the next color. So if we go look at the Binance example, it might be easier to show you. So basically we want to specify where do we want this color to start. So we want it to start right at the beginning. We want it to continue until some point here. And then after that point, we want the color to be the background. That's basically what we're specifying here. So we'll start off with the bar color. So that was the one that we defined before, whether it's red or green, basically, this bar color here. And we want to start that right at the beginning of the bar. So 0%. This is 270 degrees here, so it's going from right to left. So the start, which is the right-hand side, should be this bar color. Now, that should continue until some point in the future, and we can get that percentage by indexing into the bounds. So if you remember, it was some time ago now, but these bounds represent the different percentages of our different bins here. So the first one's at 0, then the second one's at 4%, etc., etc. So that's how we're getting the percentage here. So max bound percentage is equal to bounds I multiplied by 100. So this just converts from decimal to percentage, basically. And then we can fill in the next line here. So you want the bar color to end at this max bound percentage here. So max bound percentage, and then add a percentage sign. At this percentage way through the bar, we now want to transition to using the background color. So cell background color. And we want to use that from this point, so the max bound percentage, all the way until the end of the bar. So cell BG color, all the way until 100% of the way through. Close out that bracket there. Close out our triple string here. And then we'll do .format in order to insert all of our different colors here. So we had bar color. That's going to be equal to bar color. It's basically the same as we called them here. So cell BG color is equal to cell BG color. And now max bound percentage is equal to our max bound percentage here. Okay, that's a relief. We've got that finished here. I'll add a couple more little bits of styling here. So padding bottom 2 and padding top 2. But at that point, we're pretty much done here. We've added all the styling that we need. And if I haven't made any gross syntax errors here, which it looks like I have here, looks like there's something wrong. Yes, I need to add another bracket there. Move that -1 out here. Missing syntax down here. Yeah, it looks like I forgot to get out of this background here. All right, so it's running. Let's see what it looks like. That's a good sign. Nothing's happened. Let's examine why that might be. After having spent an embarrassingly long time debugging this problem, the problem was that we're using the price here, where we should be using the quantity. So quantity. Again, an easy error to make here, just substituting one variable in for another. So what was happening here is that because of the nature of order books, or at least for ETH/USDT, on each price level here, the price is significantly higher than the quantity, and therefore none of these values were getting colored in. But now things should be working. If I press run here, there we go. We're getting our nice styling here, and it should work for all levels of aggregation. Aggregate up to $10 here. You can see we're not getting very many price levels here, but that is just because we're not collecting enough data. You've been through this video now, you know where it is, down here. We can change this up to 5,000. And of course, if you have your own order book that's got deeper levels than this one, you'll be able to go even higher and collect even more data. So we could go to 10 here. And now we've got all the different levels in the order book. And it's not even that bad in terms of lag here. You can see this is taking a couple of 100 milliseconds, which is completely acceptable, really. Although it's moving up quite quickly. What I'm going to do here is one final check just to make sure everything's working. So I'll aggregate this down to like a penny. Let's move this over here. Grab our Binance screen here. I want to look for an asset called B dots dot. Not that one. B dot. I'm just picking it because it's a very low liquidity asset. Therefore, if we compare this to our order book, hopefully our figures will match up here. So aggregate to 0.01, 35, 553.73, perfect. 0.630, 0.341. Yep, I can put this up to 3 significant figures. And there we go, it looks like our order book is aggregating exactly the same as the Binance one, which is a very, very good sign here. One thing I might do here is just change the mid price so that it has a few more levels of accuracy than everything else. This is optional here, but it just means that our mid price doesn't look dumb when you're aggregating to higher price points. So we'll set a variable called mid price precision here, and I'll just set that equal to quantity precision plus 2, let's say. Convert this to an integer because it's a string, and now shove it in here. Mid price precision. Let's go have a look at that. There we go, that's a little bit more accurate. While we're working on the mid price here, it might be a good idea to move them above the aggregate levels here. Otherwise, it's going to be unnecessarily rounded because the level's going to get aggregated here. So let's try that out. It looks like that is not quite right. Let's see what's going wrong here. If we print out the bid and the ask prices, we'll see what's going on. So bid price and also the ask price here. We should be able to see what's going on. I'll get rid of anything else that's been printed out. So we want the largest bid and the smallest ask, which means that we want the 0th element of both of these rather than getting the last one, which should be easy enough to fix here. So rather than -1, we have to change this to 0. That's just because we've moved its position now. Previously, this line was after here, where the values get sorted, and so they're in a different order now. If we check that out, that is looking much better to me in terms of being an accurate mid price. Let's just check if we aggregate this to a higher value. It's still going to display the real mid price. One thing I forgot to mention during the initial recording here is that if you use text align center for these different tables here, if they have different magnitudes on the left hand side, so you can see this is 10,000 whereas this is 8,000, you'll notice the dot here is slightly off in alignment, which can be quite irritating. And so if that does annoy you, a very quick fix is to just right align everything. So if we go back to our data tables up here, we applied a right align to them. So text align center. And we can just align right here. And that will fix the problem for us. Although it will, of course, not be centered anymore, which, again, some people might dislike the aesthetic of this. Another approach that you could take to fix this, if you wanted to keep things in the middle, would be to align everything to the right and then add some padding on the right-hand side. So we can add some padding in here. Let's say something like padding is going to be 30 pixels. See what that looks like. It looks like I added padding all around. I meant to add padding right there. So you can see the effect that this is going for here. Maybe I need to add something like 60 pixels. Okay, that's too much. Let's tone it down a bit. Let's go to 45 pixels. There we go. That looks a bit more reasonable. Although this will have the effect that when you change the precision here, these will move about. Or they'll get closer and closer to this edge. They'll be less and less centered. I'm sure there's a fancier solution that you could implement where you take the number of characters and then account for that in your padding. But that might take an hour-long video in itself. If you made it all the way to the end of the video here, I believe a congratulations is in order. If you followed this video the whole way through, you'll have acquired a wealth of new Plotly Dash skills that you can put to use in building more advanced dashboards, like the one we see here. And if you're interested in more of these kinds of projects, there'll be a playlist in the description where you can find my other tutorials on Plotly Dash. So I hope you enjoyed the video, and I'll see you in the next one.